Hi everyone, welcome to our paper presentation at IEEE VR 2025 called Comparing Absolute Size Perception and Optical See-Through Augmented Reality and Real-World Viewing using Verbal and Physical Judgments. This is the work of the master's student in our group called Chao-Kuo or Vincent Chiu. We know that accurate perception of size is important in a variety of situations such as shelving, as well as in the accurate placement of objects judged by the size of gaps. And we know that size perception is informed by information that is quite unreliable, such as perspective projection and retinal size, and invariant information such as texture gradient that is occluded by the foreground object, as well as size and shape constancy. And AR applications are used to train users in a variety of real-world perception action tasks, such as the image on the right that shows AR training being used by the BMW group. And we know that size judgments can be made via cognitive recall using higher-level conscious cognitive processes, such as verbal responses, or direct perception action, such as immediate physical judgments. And given the popularity of optical see-through augmented reality headset, we need to understand how size perception differs between augmented reality as compared to the real world. Therefore, our research questions and hypotheses in the study that we conducted was as follows. We examined to what extent does absolute size perception differ between OST AR and real-world viewing when using verbal reports and physical judgment methods. Our first hypothesis was that the absolute size perception in augmented reality would be more erroneous than the real-world conditions, as we know that users tend to erroneously perceive depth of objects in OST AR as compared to the real world, and the color and ambient illumination of the environment have been shown to affect object saliency and opacity in optical see-through augmented reality. And the second hypothesis was that the absolute size perception using verbal judgments would be more erroneous than physical judgments. And we know that verbal reports are found to be more erroneous in spatio-perceptual responses as they rely on abstract cognitive processes, whereas immediate physical judgments utilizing direct perception, proprioception, and real-time sensory input tend to be more accurate. So we conducted an experiment which was a two-condition AR versus real world by two-judgment method, verbal versus physical judgments within subjects' repeated measures design. The target cubes varied in size from 20 centimeters to 60 centimeters, and there were 5 random trials per target size that resulted in 30 trials per judgment method per viewing condition. And so there were totally 60 trials with 30 verbal and 30 physical judgment trials for each viewing condition, AR or real world. We recruited 16 participants, 8 males and 8 females in our IRB accepted study, and all participants had 20/20 vision or corrected using contact lenses. Participants' stereo acuity and IPD were carefully measured, and all participants had little or no experience with AR or VR viewing, and participants' age ranged from 21 to 38 years old with a mean of 25.19. So let's watch a video of the experiment procedure and simulation.
Participants were seated on a chair perceiving the object on a table for several trials, and they were asked to estimate the size of the object verbally and physically using their hands. For both the augmented reality and real-world condition, trackers were attached to the back of the participants' hands. At the beginning of the experiment and after every 3 trials, participants were asked to hold the reference object with their eyes closed. In the augmented reality condition, participants also wore an optical see-through head-mounted display. This is how it looked in augmented reality condition in our experiment. After perceiving the target object, participants were asked to cover their sight and then reported the width of the target object in relation to the reference object immediately. Then, participants looked at the same object again. but this time they used the distance between their palms to judge the width of the object with their vision removed. In the real-world condition, participants perceived real objects placed on the tabletop, and they were also asked to report their sizes both verbally and physically. The procedure was the same as in augmented reality.
With regards to results, when we conducted a multiple regression analysis, first comparing AR versus real-world viewing, and what we found is that with regards to verbal reports, size perception in AR showed underestimation than real-world, and we also found this to be true in physical judgments as well, but they were not as significantly different as compared to, say, verbal reports. And in both physical judgments as well as verbal reports, real-world judgments are more consistent as compared to augmented reality viewing, as shown by the R-squared values. Multiple regression analysis also comparing verbal versus physical responses showed that generally physical judgments were more accurate than verbal reports, and this was shown to be true in both AR viewing as well as real-world viewing. But interestingly, verbal reports are more consistent than physical judgments in both viewing conditions. We also measured the accuracy, which was the residual error between perceived size minus the actual size, and we found that when it came to AR viewing and in verbal reports, participants were more accurate in real world as compared to AR. But in physical judgments, participants showed slight underestimation in AR, whereas a slight overestimation was found in the real world. When we also looked at the accuracy scores with regards to augmented reality and real-world viewing, within augmented reality, we found that both physical judgments and verbal reports show underestimation, with more underestimation in verbal reports on average. And within real-world, we found that verbal reports showed significant underestimation, whereas physical judgments showed a slight overestimation on average. So in conclusion, we find that the absolute size perception in augmented reality was found to be more erroneous, meaning highly underestimated, than in the real-world condition when it came to verbal reports. Interestingly, physical judgment showed only slight overestimation in real world, while slight underestimation in augmented reality. So we find that hypothesis 1 was only supported with regards to verbal reports. So overall, we find that it was partially supported. The absolute size perception using verbal judgment method was found to be more erroneous with a large underestimation as compared to that of the real-world viewing condition. So we find that hypothesis 2 was fully supported. Overall, when it comes to impact, limitations, and future work, we find that using action-based perceptual judgments of size perception in optical see-through augmented reality viewing is shown to be more accurate than higher cognitive type responses such as verbal reports. With regards to limitations, the differences in absolute size perception was compared in medium field only due to the accommodative demand of the Microsoft HoloLens 2, which was the apparatus that we used in our experiment, which has an accommodative demand of 2.5 meters distance, and that's the viewing distance at which targets were placed in the augmented reality environment as well as the real world in our experiment. And we only compared between optical see-through AR to real world viewing. However, in future work, we are investigating near field, medium field, and far field size perception in contemporary optical see-through augmented reality versus video see-through augmented reality versus real world viewing in order to perform a thorough and comprehensive experiment. So finally, thank you and questions. We also thank the National Science Foundation of the US as well as the National Science and Technology Council of Taiwan for partially supporting our research.